Now these are two linear equations in two variables, x and y. X and y could be any two numbers. Consider this equation. X plus y is equal to 9. So in order to solve this equation, we need two numbers such that their sum is 9. So we could have x as 1 and y as 8 so that their sum is 9. If x is 10, y would be negative 1 so that their sum is 9. If x is 0.5, y could be 8.5. So we would have many solutions of this equation. If we consider this equation alone, we would have many solutions. And since x and y could be any real number, we would have infinitely many solutions because we could go on changing the value of x and the value of y will change accordingly such that their sum is 9. If we look at the second equation alone, y minus x is equal to 5. That is, we need two numbers such that their difference is 5. So, if y is 6, x would be 1. If y is 8, x would be 3. And so on. So, we would have infinitely many solutions for x and y. But since this is a pair of linear equations, or since this is a simultaneous linear equations, we need to have that value of x and y which satisfy both the equations simultaneously. That is, we require two numbers such that their sum is 9 and their difference is 5. So the values of x and y should satisfy both the equations simultaneously. And how can we get those values? Let us see. From equation 2, we have y is equal to 5 plus x. So we have transposed this negative x to the right hand side and written it as plus x. So y is equal to 5 plus x. This is the same as equation 2 because equation 2 says that the difference of y and x is 5. And this says that 5 added to x gives us y. So these are the same things. So from equation 2 we have y is equal to 5 plus x. Now we can substitute this value of y in equation 1. So in place of y in equation 1, we can write this. We have substituted this value of y in equation 1. So in place of y, we have written 5 plus x. And since we have substituted the value of y, this method is known as the substitution method. Now what are we actually doing? From equation 2, we get a value of y and substitute that value of y in the other equation, that is equation 1. This ensures that while solving equation 1, we are considering only those values of y which satisfy equation 2. Because we have taken y from 2. So we are considering only those values of y which satisfy equation 2. And we have substituted it in equation 1. Now we can solve this equation because it is a linear equation in one variable x. Now we can solve this equation and get the value of x. So x plus x gives us 2x. We have plus 5. So we get 2x plus 5 is equal to 9. Or 2x is equal to 9 minus 5. That is 4. Or x is equal to 4 divided by 2. That is 2. So we get x is equal to 2. Now we have got the value of x is equal to 2. Now it is very easy to get the value of y. We can substitute this value of x in this equation and get the value of y. So putting this value of x in equation 3, we have y is equal to 5 plus 2. So y is equal to 5 plus 2, or y is equal to 7. So we have got x is equal to 2 and y is equal to 7. Now we have got this value of y by substituting the value of x in equation 3. We can get this value of y by putting the value of x in 1 or 2 as well. So we can put this value of x in any of the 3 equations and solve for y. We'll get the same answer 7. But it is the easiest to put it in this equation because it is already in the form of y is equal to 5 plus x. So it is already in the form of y is equal to something. So normally it is the easiest to put this value of x in this equation. Now we have got the solution. X is equal to 2 and y is equal to 7. This solution satisfies both the equations simultaneously. These are two numbers such that their sum is 9. Also, y minus x, that is 7 minus 2, gives us 5. And we have got this solution by substitution method. Observe that when we considered the equations individually, we got infinitely many solutions for each equation. But when we solve them together, we get a unique solution. So we require minimum 2 equations to get a unique solution if we have 2 variables. And we can solve a pair of linear equations in 2 variables using the substitution method.